Yeah, in this video, we are going to see about my project MedVox, AI-powered real-time medical voice assistant. And we have done this as a team, and my teammates are Kirtana and Darshan, and myself, Narmada. And my guide is Dr. C. Anna Palagan, sir. And the agenda of this video, in this video, we will cover introduction, statement of the problem, scope of the project and methodologies, which includes architectural diagram and flow diagrams, algorithms used, which we have used in this project, and also we will display use case diagram, class diagram, and as well as a sequence diagram. And in final, we have output. Also, we have in this PPT, and also we will talk about future work. And yeah, this is the introduction for our project. MedVox is an AI-powered medical voice assistant designed to improve communication between doctors and patients. It's rush period, don't have that much time to visit hospitals and doctors. So using our application, the patients can communicate with doctor through the screen and chat and also in video calls or call recordings. And it helps convert spoken medical conversation into clear and accurate text instantly. The system supports healthcare professional by reducing manual note taking and saving valuable consultation time. And MedVox makes the healthcare interaction smoother, faster, and more accessible for both doctors and patients. And the statement of the problem is the problem at hand is ensuring accurate and efficient communication in medical environments through real time voice interactions. In healthcare, even minor transcription or interpretation errors can lead to serious consequences, diagnosis, and treatment. And existing voice assistants often struggle with understanding complex medical terminology, context shifts, and low latency response. But in our project, there will be no struggles for the medical terminology like complex words. The patient will have the easy words which they can understand. And the scope of a project is it is mainly focused on developing an powered medical voice assistant that converts medical conversation into a accurate real-time text. Then improve clarity, communication, and documentation efficiency in clinical environment. Reduce manual note taking, support doctors in capturing medical details more effectively. And the target audience are healthcare professionals, hospitals, and clinics. Then in our project, we have inclusions and exclusions. Capturing and converting spoken medical conversation into structured text is one inclusion in our project. Then handling medical terminology with high accuracy, providing summarized and organized outputs to assist doctors. And exclusions are no diagnosis or medical decisions making and does not replace clinical judgment or professional consultation and not built for emergency critical or life saving decisions. These are the exclusions of this project, and these are the data we have used. Data will be collected from the conversation of the doctor and patient, and it will reduce the noises and cancel the background images unnecessary. It will only focus on the conversation of patient and doctor. Then it will pre-process to handle background noise, accents, and speech variations. Then limitations or data constraints, resource limitations, and accuracy dependence. Performance may vary with heavy accents, noisy environments, or rapid speech. And these are the methodologies we have used in our project and portal using MERN stack. First, we will collect the data like the conversation between the patient and doctor. Then we will pre-process those audio like collected audio files or cleaned using noise reduction, silent trimming, and normalization. Speech segments are extracted and converted into consist formats for model training. And the models we have used is NLP and AI model development. We have used speech to text and natural language processing models are developed into accuracy understanding. Then response generation model. We have used Gemini for the response AI. It will respond accurately as what the patient is asked to the bot. Then we have a web and a mobile portal development for user interface. The users can easily access the application. Then integration of AI models with portal is speech to text and natural language processing. Response generator models are integrated into the backend API. Then we have testing and validation. These are the steps we have done in our project. And as I said, we have used two like two ML models like speech processing includes and NLP. The speech processing includes collecting and pre-processing medical voice input, as I said, converting the speech into text using an advanced ASR model, and extracting key medical terms and inputs from the transcription. And NLM uses the understanding medical context using LLM based processing. As we have used Gemini 1.5 Pro. It is very highly LLM based processing. So it will give you accuracy for what the patient is asking and identify symptoms, conditions, and relevant information, generating safe, accurate, and context aware response. Then this is the architecture diagram. We have used front end, back end. For back end, we have used Node.js and React, and we have used ML models and Flask app. And for MindBot, we have used Gemini API and Consultant. The data will be stored in database, which is here healthcare database. And this is the another architecture diagram or flow diagram. We have three layers. First layer is client layer, which we can record our recordings and can send to the application. Then there's another layer which is called AI processing layer. It will pre-process the audio, then converts the speech to text, then LLM medical understand, then response generate the text to speech. Then the final layer is backend layer. We have used Next.js streaming pipeline and API gateways and database to store data. And this is the UML diagram of use case. And yeah, these are the things the patient will do in this application. The patient will book appointment, and the patient receive notification, and the patient access medical advice, which is done by MedVox system. MedVox system will give the access medical advice. Patient manage appointments, and patient provide documentations also in online, and MedVox system will provide recommendations by going through those documents. Then AI based decision support system manager access are also done by patient. And this is the class diagram. It will store the patient's data, MedVox system data, and doctor data. And so these are the databases which will stored. And this is the sequence diagram, same as the use case diagram, with a clear movement of patient and application. And these are the algorithms we have used in our project. Logic regression is a robust statistical algorithm used for predictive analysis and classification. It's used to predict potential disease by analyzing the binary input vector of user selected symptoms, and it will provide high accuracy disease classification as 99% by modeling the probability of a specific condition. And the another algorithm we used is Gemini 1.5 Pro, as I mentioned earlier. Gemini 1.5 Pro is an advanced large language model which will have the accuracy, and it is used to power the mind bot for empathetic mental health support and to explain medical diagnosis in simple terms. And it is a generative AI model that maintains conversation context to provide personalized health advice. Then these are the hardware and software selections we have used. Like hardware requirements are processors and RAM, 8 to 16 GB, and the 10 plus GB storage should be available in your system. Then GPU optional, we can use this graphical process unit also. Then software requirements we have used in front end is React.js, HTML, and tile components, and we have used Tailwind CSS. And for backend, we used Flask by Python. Then ML algorithms are logistic regression. ML libraries we have used Pandas, NumPy, and Skylern. API is a Gemini API, and database is Firebase Firestore. Tools we have used in this for Google Colab, Google AI Studio, and Postman VS Code. Mostly we used VS Code and Postman. And these are the implementation. We have included the libraries like CV and PyTorch. Environment setup and library import. We have used PyTorch, Keras, NumPy, Pandas, and Matplot, which are essential for model training, data handling, and visualization. Then configuration parameters are initialized, and data processing and analysis are readiness. And these are the code. This is done in Python, and this is done in front end code. And yeah, this is the output. After we done our work in front end and back end, our output is like this only. And this is the home page. It contains all dashboard systems. In dashboard we can see all the symptoms analysis, Mindbot, and consult doctor. This is the main page of our project, and this is the symptom analysis. In this, we can the patients can type their symptoms and press the button analyze. After clicking analyze, the A will give you the accurate symptoms as what you have and what is your actual problem, and it will recommend some medicines. And the next one is mindbot. In this we can text to AI, and it will give you the accurate answers and results. And we can consult a doctor also in this, and we have provided the reviews also. By seeing those reviews you can consult your doctor. Each doctors are specialist in some field. Like in here Dr. Mayan Iyer is a specialist in neurologist. Like that, for each each field we have some specialist doctors. And these are the test cases, the user login, image upload, prediction result displays. And results are accuracy. Accuracy is 90 percentage, precision is 93, and recall is 92. And the conclusion, yeah. To transform healthcare communication by providing accurate real-time speech recognition and intelligent medical response generation. This innovation enhances communication accuracy, reduces workload of patients as well as doctors, and contributes to improved efficiency and patient care quality in medical environments. And these are the future work. We are still working in our project to get the 100% accuracy. As of now we have only 90% accuracy. To increase that accuracy we are working in this like enhanced medical accuracy by integrating advanced domain specific medical LLMs and multilingual voice support to assist diverse patient groups, and implement real-time EMR and EHR integration for automated clinical documentations. And these are the reference we have used for our project, and they helped us very well.